greatest folks building on AWS and building AWS. So my name is Nathan Peck. I'm a developer advocate at AWS, joined by my co-host.
My name is Brian Terry. I'm a senior solution architect focusing on ISV integrations. And if this is your first time joining us, welcome. So I'm here joined by an awesome guest. He's got an awesome demo, spoiler, and we're going to see some really cool things. But first, let's let him introduce himself.
Hey everyone, I'm Vivek Bhakta. I'm a co-founder and head of infrastructure at WOMBO. We're an AI company. We build consumer apps for the masses. The reason we started this was we saw that there's a bunch of state-of-the-art models that researchers spent thousands of hours building, and they just sit on shelves, and they're really fun and amazing to use. And so we launched our first app, which is like a deepfake app, and it went pretty viral. It was pretty fun. You take a selfie, pick a song, and you start singing and dancing, head bobbling around. And then now we're demoing our text-to-image app that we launched a year and a half ago, or about a year ago.
Wow. Okay, so I hear your mission goal is to kind of bring models to the masses.
Yeah.
I think the best way to really understand what these AI models do is to see it in action.
Sure.
And I understand that you're going to be able to demo some text-to-art
Yes.
live.
Whoa.
I'll go ahead and share that.
Yeah, let's bring up the demo.
Yeah.
We good to go?
Yeah.
All right,
Yeah.
so here's the web app. We also have a mobile app. In the web app, as you see here, you have a text prompt. So we're here in Vegas for reInvent, so I'll go ahead and type in Las Vegas Strip. And I'll pick a art style. So I like diorama a lot, and then I'll create. And then live, as the AI is generating and creating your piece of art, you get to see it here.
Wow.
And you can go and try this right now at dream.ai. Feel free to play around with it. And then you can also try different styles, and you'll get different kinds of renditions.
Yeah.
Okay, so if folks watching right now go to dream.ai, they can try this out
Live, yeah.
also. They can put in their own phrase and see what it generates.
Do you guys have any phrases you want to see?
Let's see, how about a lighthouse? I see a lighthouse on there.
Lighthouse. What style would you like? We got a ton of styles here.
Let's do spectral. Spectral, that looks spooky.
Spectral. Where we got spectral?
Oh, surreal.
Surreal, yeah. Oh, spectral at the top, I see it. Oops.
Wow. This is really cool.
Wow.
Yeah.
So once you generate these images, what else can you do? Can you print them out?
You can print them. So you can go ahead and print this out on a piece of canvas or just as a photo, as like a poster. You can paste it on your wall. You can also create it as an NFT if you want. And the beautiful thing here is this image right here that we've generated, you cannot regenerate again. And so this is like an inherently unique image, which plays really well with NFTs.
Oh, interesting.
You can connect your wallet up and mint these.
So every time it generates this, it's generating a brand new thing that has never been seen by anyone else yet.
Correct.
Wow.
So you're telling me I can just type in a couple words and I can just be an artist. I got a one-time, one-off piece.
That's right. You can even upload your own images and draw on top of images. So I'll show you that really quickly here.
Yeah.
You want to do spectral? I'll do spectral lighthouse. And so you see we have some sample images you can do, or you can upload your own. We can pick like this piece of this. And then you can select the strength of your image. So do you want a very high influence of the input image?
Yeah,
and if you want that, we can go ahead and click create. And then what happens is the AI tries to draw on top of the image. The stronger the influence, the less you'll see like a lighthouse. So like you'll see like lighthouse wasn't really built here, but if I decrease the influence of the image a little bit, you'll see more of the prompt being represented in the final output.
Man, I think you
So
just
nice,
introduced
yeah.
me to my
Lighthouse.
favorite new toy now. I'm literally going to be playing with this
Yeah, it's
directly
free.
after this.
Feel free.
And I'm going to have this all plastered across my house. This is awesome stuff.
Now, obviously, you mentioned this is model-driven.
Yep.
I imagine there's a lot of compute resources that happen behind the scenes because this is some high-quality art too. Like, and I noticed it generated fast.
Yeah.
I've seen some of these models. They sit around for 5 minutes before you get a response back.
Right.
So I imagine you must be doing some really powerful compute stuff behind the scenes. Can you tell us a little bit about?
Yeah, of course. So we've built native or digital native on AWS. So everything since the company started has been on AWS. We use GPUs on EC2. I can share the architecture diagram I have here.
So let's jump into the architecture.
Cool.
Wow.
So here's the diagram. I'll walk you through it pretty quickly here. So on the web app, you saw that I typed in a text prompt and I clicked a style and click create. So we hit our APIs through Global Accelerator, which is on the backbone of CloudFront, and that hits our Fargate API. So we have a bunch of API nodes living in Fargate, which are all fully managed with AWS, which is great. No need to manage servers.
And so this is the front end, I'm assuming. It's generating back the HTML for the website.
No. So this is just for our generations. The front end is running on Amplify using Next.js, which is
so that's the part that's coming straight out of Amazon S3. Then.
Yep. Yeah. So this is the actual generation, the backbone of kind of all the cool stuff that we build. So we hit the API. The API goes ahead and says, hey, you want to create a piece of art or a deepfake? Send your task to a queue. So we use SQS here. And then we have a pool of GPU workers reading from the queue using Celery. It's a Python package. And so it reads from the queue, and basically whenever there's a task to be worked on, the GPU instance will pick up the task, work on it, generate the images, send them to S3, and then send that via CloudFront and deliver that to the client.
Yeah.
Wow.
And then so we have also like our database to store task information, metadata, and then user information like how many dreams you've created and like publishing. So you'll have your own gallery as well that you can see. I can show you that. If I just go to like dream.ai/profile/Vivek, you can see like a profile of published artworks that I have.
Wow.
And then, so that's all in RDS. And then we use Elasticache to make sure we can deliver the content very quickly.
Nice.
Yeah.
So I noticed a theme in here. You're using AWS Fargate for containers. You're using Amazon ECS to orchestrate these GPU instances. Tell me a little bit about choosing containers. Like why did you choose containers for this architecture? What are the benefits?
Yeah, that's a great question. Containers just make the development process a lot simpler. So you'll have the AI team develop their ML container, and then what they'll do is they can just quickly deploy that and scale it out without having to worry about dealing with setting up the compute, any of the underlying compute. They don't have to go and install packages. It's all in the Docker file. It's very seamless. And then you can also, the other benefit of like ECS is we're able to quickly scale up and down instances. We don't have to deal with any nonsense. It's pretty quick. And you have auto scaling groups on top of that, which we have some cron jobs running to send metrics to, and it's fast.
So if viewers watching right now go there, they can start generating some art, and it's probably going to trigger some auto scaling.
That's correct. Yeah.
I'm definitely going to trigger some. This is very cool. Do you have any advice for people that are working on containers in this space?
Yeah, so I think everyone should be working on containers. And people say, when you have like crazy HPC workloads, like high performance compute workloads, containers kind of can be a bottleneck. And this is probably true for people working on, like quantum and stuff like that, where containers aren't even supported yet. But we're doing pretty heavy ML workloads, and containers have been able to scale it up pretty quickly. The one issue we have seen is our image size gets fairly large, and so trimming down your base images is huge for being able to start the container quickly.
So I imagine that size, it probably comes from the model itself. Like the model has to encode essentially visual information from millions and millions of sample images to kind of understand the visual makeup of the world in order to be able to turn text into an image again.
Correct.
So that model must be pretty large in size.
Right, yeah, and so we need to make sure that we're trimming that size down as much as possible, and then pulling in data once the container started. So what we do right now is we've tried to remove as much of the weights as we can, put them in S3, and also we have some in Elasticache, so we just fetch it, super quick retrieval times.
Yes.
And so the container can start, and then it can download and pull in the rest of the stuff.
So you're storing the model outside the container, and then when the container boots up, it's able to pull in the model out.
Exactly.
Yes. Yeah.
And the reason for that is the Docker images that live in ECR are, I believe, backed by EBS.
Yes.
And so when you pull that, there's a different latency versus when you pull it from S3, and the larger that is, there's some penalties sometimes.
Yeah, that makes total sense. I've seen some folks that they try to put the model itself inside the image, but then they're waiting on ECR to deliver that image down, and that might be a lot longer of a startup period compared to pulling that, like you said, you're using even Elasticache to cache some of that data to pull in very fast.
Correct.
And this goes to speak how you can just take this one technology where you got containers, and then you can keep bolting on AWS tools to reach the architecture
Correct.
or the time limit you want to have in the API. I mean, this is great. It's a perfect example.
Yeah, and it was great because what you just mentioned was baking the model into the image. We were doing that initially, and then we spoke to people on the ECS team.
Yeah.
Thanks to our account team, they were able to put us in touch with the ECS team, and they told us, hey, this might work better. And I was like, oh yeah, it makes sense when you say it after that. But we're thinking, okay, let's pack it in the image so then it's ready when you're booting. But we learned how things work under the hood a little bit, which has been nice.
That's awesome.
And so let's talk about scaling as well. Like obviously, this is the type of application that maybe has a little bit of a viral aspect. Different cases where a lot of people maybe try to start playing with it. What did you find in terms of learning how to auto scale this type of workload on demand?
Yeah, that's a great question. So on the note of virality, actually recently in May of we're in 22, right? Yeah, May of 22. We were the #1 app in the App Store and the Play Store for about 2 weeks straight around the world.
Yeah.
And that brought a lot of traffic to the app. And so making sure we had enough compute, like GPUs, our database was able to scale, all these things was not something I was taught in school. It was not something that, I'd done ever at any other previous job I've had. And so we were quickly trying to figure out how to scale, and we reached out to our support team, which has been, phenomenal for making sure we can scale properly. Scaling is really tricky though, because we were talking about those model start times, the container start times, I mean, and you need to make sure if, as a user, you're playing with a mobile app and you're trying to generate an image and you're like, hey, if this isn't quick like the rest of the things, like when I open Facebook, Twitter, Instagram, it's instant, right? And the end user doesn't care that it's AI or ML or whatever under the hood. So we need to make sure we can provide a super fast experience for our users.
And even then, I saw in the architecture diagram, you have that SQS queue in the middle to kind of absorb spikes. So if the auto scaling can't adjust instantly, that work is not going to overwhelm the front end API. It's going to be stored in that queue.
So their tasks are still safe. You'll eventually get it, and we want to make sure you get it within. We have an SLA internally of about 10 to 15 seconds.
Nice.
On GPU it takes about 3 to 4 seconds, but we know there's other latencies involved. Of the user has to download it on their mobile data connection or their Wi-Fi. It has to be quick enough to send all the requests back and forth. And so there's other intricacies involved.
So we have an interesting question on Twitch chat from Johnny Code. He says, curious why the choice to go with Fargate and ECS over EKS?
I was just going to ask the Fargate question.
So we are a pretty small team. We don't have a lot of Kubernetes experts, though. Fantastic question, because I just spoke with the EKS team, and I'm looking to move some of our workload over to EKS. Because you always see the memes and the tweets and the DMs, all sorts of commentary about how you don't need Kubernetes. And we didn't have this scale when we launched. And so we're growing into it. Definitely ECS makes it super easy. You don't need to know anything about Kubernetes, even though ECS is kind of like an orchestration platform, just like Kubernetes. It's less involved, and there's a lot more managed for you through AWS. And I don't think there's an extra charge for it.
No, it's not.
Exactly. The control plane itself is free. There's not going to be any cost for it.
Exactly.
And it seems like there's a tighter integration with other AWS services too.
And we can set up auto-scaling groups pretty quickly. With Kubernetes, we've learned that with Carpenter, we can interface directly with the AWS EKS APIs and the EC2 APIs to provision instances. And so that's what we're going to start moving towards. But fantastic question.
Well, I'm a big fan of that type of approach. Start with the technology that helps you build your MVP quickly.
Exactly.
Especially if you're a startup. You don't want to have to build out a big team of Kubernetes experts from the beginning. This allowed you to get off the ground, get that #1 position on the Play Store, and App Store, like you said, and then you can experiment with other technologies.
Exactly. And it's hard to make that investment early on, especially in the startup world where we have a small team, and it's like, hey, we can get up and running on ECS in a day, but we can take maybe 2 weeks to get everything on EKS because we just don't. We'd have to sit there and learn it. And there's also other product features coming in that we need to support, and so it's a balancing act.
Yeah, even when you did ECS, you use Fargate. You could go the direction and use instances and then run ECS, but having Fargate allows you to have like infinite scale. Right?
Exactly, and we don't have to worry about storage or any of that. What you normally have to worry about in traditional
patching
servers.
The underlying instances and that kind of stuff.
And do you see this architecture growing over time? Maybe as you have like more microservices, more different types of features.
So this is actually a simplified architecture diagram. There's a lot of other stuff under the hood. We have so you saw the uploading the images and stuff. We have a media store API to save on bandwidth costs and to also make it faster for our user. So basically, if you upload an image, we can cache that for some amount of time. We have it for 72 hours, a week. You can set it up. And on the client, we have a way of tracking, hey, okay, this image we already have. No need for the user to upload it to S3, which is something we've learned from our first app where you're uploading a selfie every time. And so it's like, wait, I've already used this face. We have the face gallery. Why are we uploading it? Because the user's internet connection might be bad or whatever, and the upload speeds, the user doesn't know that you're uploading an image, or they're unaware of like kind of the bandwidth stuff, and we don't want them to have to know that stuff because we want to make it easy to use.
That's a smart optimization. I like that. Yeah, cache as much data there in S3 as your object store, and reuse that. Track that information in Elasticache. And I did want to ask about that too. Like I noticed you have Elasticache and RDS there. Oftentimes I hear people ask like, why multiple databases, why multiple different types of databases? What do these different persistence stores like do for you in this case?
Fantastic question. So RDS is mainly relational data. Like you saw, the task data, task metadata, your gallery view, which stores like persistent data that you want to make sure that you can still see your gallery in a week. Things in Elasticache are for quicker access. So like our rate limiting, all that stuff lives in Elasticache because we don't want to have to wait for every API call to check, hey, let me go check this entry for this user in the table, which will be a lot slower than Elasticache, which has sub 100 millisecond response times. And so for speed, we use it exactly for caching.
Yeah, because that way you can rate limit with the Elasticache without hitting the database every time. Yeah. And we got another question in the chat asking, I think about observability. Are you using AWS X-Ray or any other tools? Like, how are you keeping track of everything inside your system?
Fantastic question. We weren't for a long time. Because we're just moving very fast, and then we're like, wait, there's just too much going on.
You're still building everything
exactly.
and maybe changing things. You don't even know what to monitor yet.
Exactly. So we started leveraging OpenTelemetry, and so we've implemented OpenTelemetry across all of our services, our ML workers, our API nodes, all of it. And we have like a open source tool called Signos, fantastic tool, highly recommend it, that we can host it ourselves in EKS. Yeah.
So before we run out of time, where do folks go to get started with this? And I understand you had a special moment recently. Yeah, so as of today, we were just announced publicly now that we are the #1 app, or like the app of the year by Google Play. Wow. So the Play Store marked us as the #1, or like the app of the year, which is amazing. For a small team, we have one Android developer, and he's amazing. It's super cool to have been able to have won that with such a small team as well. Great status. And what was the URL again for everybody who wants to try it out? The URL that is dream.ai. Dream.ai. Yep. All right, thanks so much for telling us about this architecture, and best of luck with your future developments. It was a pleasure. Thanks for having me. Thank you.
Yeah, and stay tuned for us on AWS On Air, Reinvent 2022. There's more to come, so we'll be seeing you soon.